Hey guys, what's going on? So today we're going to be looking at parts of similar triangles. So first we're going to kind of review some sides or types of heights or sides within a triangle that we've seen before, but it has been a while. So for the first one, we have something like this, where it just goes straight down and forms 90 degrees. Okay, this is an altitude. Okay, and you can identify it with the 90-degree mark. Okay, and also what's different about this section versus the previous sections we did is in the previous sections we sort of proved that triangles were similar. In 7.5, we're looking at parts of similar triangles, meaning we're already working under the assumption that these triangles are similar. Okay, and by definition of them being similar triangles, their sides are proportional, so we can set up ratios based on that fact. So first ratios is we can say that BD, that altitude, over FH, this altitude, equals, and then we could say BA over, and then FE. So notice this too, all my sides that are in the numerator are all from the same triangle, and same with the denominator. Okay, then we also have BC, this would equal BC over FG. And these shouldn't really be a surprise because again, they are proportional. So really the only new type of ratio really that's here is the fact that these altitudes would also be proportional. Next, so we got sides like this. Okay, this is an angle bisector. Which, don't forget, just means it cuts an angle in half. Okay, so you can identify it with the angle congruency marks that you see over here. So very similarly, similar logic, we could say that angle bisector QS over UW, I'm going to put the little swoosh in my U so that way it's not confused with the V, would be equal to QP over UT, which is also equal to QR over UV. Okay, last type of side. Okay, we got this guy here. This is a median, and it cuts your base in half. Okay, so we could say HJ over LN equals, and then we could say GI over KM, which equals HI over LM. Okay, and then sadly, on y'all's notes, what is debatably the most important thing from this section was missing, so you would actually have to write this part down, okay? That's in the highlighted section. Sum it up, it says if SO, it's called the triangle angle bisector theorem. It says if SO is an angle bisector, okay, meaning that it, cuts this angle into two equal halves, then, and then it says SD, okay, so we got this SD over SG which is this guy right here, equals OD over OG. Okay, so basically what this is saying is that if you have a triangle, okay, with an angle bisector, then you could say that this whole side over this whole side equals this part over this part. So whole over whole equals part over part. Okay, now as long as you keep the wholes in one fraction and parts in one fraction, you're okay. And you need to check off one more condition. Notice that SD, which is on the left-hand side of the triangle, and OD is also on the left-hand side of the triangle. So basically, you have whole over whole equals part over part, where you're consistent on the left-hand side and right-hand side both being on the same side of the fraction. Okay. So speaking of that triangle angle bisector theorem, we're going to use that right here. So it says, given QS is an angle bisector, solve for X. So it's already telling you that QS is an angle bisector, okay, which already tells you that you can use the triangle angle bisector theorem. So you're going to have whole over whole equals part over part, and you just stay consistent on the left-hand side and right-hand side. So let's just set it up. Whole X over your other whole, 35, equals, and then we got part over part. So parts, I did put X of my numerator on this fraction, and it's on the left-hand side, so I need to put the left-hand part on the same side. So part over, then they gave us kind of a tedious step here, right? This whole side is 70, this part's 42, so this part's going to be 70 minus 42, which is 28. Okay, then from here, you can just cross multiply and solve. So you have 28x equals 1470 using the cross product rule. Divide that 28 over, and you get x equals 52.5. Okay, let's move on to the next. Okay, and on this unit 2, to know when you're going to use what. So when I have one triangle and an angle bisector that kind of splits it into two smaller triangles, I'm going to use triangle angle bisector theorem. When I just have two separate triangles, I'm just going to use common scale factors like we went over in the very beginning. Okay, so number 3 says triangle STU is congruent to triangle DEC, and it doesn't say it, but I think it's safe to say that it means to us to solve for X. Okay, so just start setting up a ratio. So let's do X over 15, these are corresponding sides, equals, and then for your other scale factor, okay, you can remember, because they have to be corresponding sides, you can look at your triangle similarity statement to get that, or also this we can do that this is my smaller number, this is my larger number, this is my smaller number, this is my larger number. So the smaller numbers are corresponding sides, the larger numbers are corresponding sides. So let's go ahead and do small over small. And I started with X, which is on this triangle. So I'm going to have 16 over here and then over 20. Okay. So now you can just do the cross product rule. But also note this, if you want to make your life a little bit easier on the algebra, is you can reduce. So I could take a 4 out of both of these and have 4 over 5. Now cross multiply, and I end up with 5x equals 60, and divide the 5 over x equals 12. Okay, and that is it for a brief overview over 7.5. Thank you.